Corporate finance practice problem using OneNote future value calculation, asking the question of how long will it take before an investment doubles or triples. Don't leave profits solely to chance. Instead, use corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if you would like to, we're going to be in the tab on the left-hand side. We're in the practice problems, and then down here in number 931, future value, how long to double or triple investments. Also note that when using OneNote, you might want to check out the immersive reader. Many of our problems will be mirrored down here in the text section having a transcripts that can then be translated into multiple other languages and either heard or read in those other languages as well as English, thereby being a complement to the practice problems up top. So check those out if those sound useful and give us some feedback if they're helpful to you. We have our information that's going to be up top. We're going to calculate the information then down below on it. We'll do it using multiple different methods, a little bit different of a scenario here. So our question being, how long does it take for an investment to double or triple? Note that we don't really necessarily have to actually provide the investment, which is what would probably be done in practice. We might say, hey, I got this much money. I want to know how long it would take for me to double my money if we assume a rate of 6%, for example. But we don't really need the fixed amount, the first amount, because you can basically provide it because the same amount of time will then pass. So we will just pick a number. You could pick like 1. We're going to pick 1,000 to plug in. So we're going to say that we have a $1,000 initial investment, and then you could just work the algebra for it. So we would have a future value equation, which would be the future value equals the present value times 1 plus r to the n. We would assume that the present value would be 1,000, our initial investment. If we wanted to double it, then we could also assume that the future value would be 2,000, doubling of the initial investment of 1,000. So we then would have a figure here for future value for the present value, and then 1 plus r is going to be the 6%, and then to the n would then be the unknown. And then, of course, we have one unknown. We could solve for the unknown. I won't go through the algebra for that here. I also just want to point out that you can do this in other different ways with the use of Excel as well, and show how that is applicable with the Excel formula. So let's first look at this mathematically as we have broken it down in the past. So if we break down this equation to a mathematical equation as we've seen it before in like a table type of format, we had the initial investment, which we said was going to be the 1,000. That's going to be equivalent to this PV here. And then we had 1 plus 6%, 106%. And then to the power of, that's the unknown n. So typically this yellow number then for our equation would be the unknown. And then this number we can basically derive because the bottom line number down here needs to be 2,000, right? Because if this number is 1,000, the bottom line number needs to be 2,000. So then our goal then, of course, is to back into the number of periods. Obviously, this number right here needs to be 2, because we know that 1,000 times the 2, or 200%, would give us the 2,000. So if we then were going to back into this item here, note that we could, of course, do that algebraically using our formula up top. But if you had something like this that would be in an Excel sheet, and this is more transparent, which we actually could use the algebra, but if you're using a function, like a future value type of formula function within Excel, it's more difficult for us to basically back into a different unknown within that same equation. What we can then do is use something like a goal seek. There's a goal seek feature, meaning, in other words, if I had this calculated in Excel, I could basically keep changing this number here. I could start with a fixed number like 5, or just pick a number, and then try trial and error until I get to a number that's going to approximate what my end value will be. That's one way we can basically find the answer through trial and error. And we can do that with a feature in Excel, which I highly recommend going in and taking a look at, so that you can then practice using a feature like that, and it's called goal seek, to do that. Now, again, if we knew the algebra for something, we can go ahead and solve for the algebra. But it's useful to look at the algebra and see how you would do that first. You would be basically just plugging in this number and letting everything else work out itself, because you have a spreadsheet. It can do that fairly quickly, and then you just tell Excel to basically do that for us using the goal seek feature. And then if we apply that same concept to something like a formula, I'm going to jump down here to the use of the formula. this would be us solving this problem basically with a formula. Now, this would be similar to what we might do in practice. If I was to solve this in practice and say, okay, I have 1,000, I want to know when it's going to double, what I would like to use is this function in Excel to do it. So I may not even know what the actual formula is. I don't really need to know because I'm going to put in this function. It's going to give me the answer. But this function, of course, is to solve for the future value. And what I'm really looking for is the time frame, which is going to be the number of periods right here. So what I would want to do then is, instead of me looking for another function in Excel, which is going to solve for the number of periods, which they may have, but is far less common than the future value formula, I could still use this future value formula and use the same kind of method to solve for the one unknown. In other words, as long as there's still only one unknown here, I could use the same formula and goal seek to do basically the algebra, but instead of doing the mathematical algebra, doing a trial and error format to find the figure that fits. So in other words, if I was to fill out this formula, I'd say this is going to be the future value. The rate is known. That's going to be the 6%. The number of periods, that's the unknown. So what do I put there when I start? I have to put something there. We can plug in some number that we can put into a formula down here, which would be like, we can start with 5 or 10, and then just put a random number there so that it can still calculate it, and it can pick a cell on which it could change once we do the goal seek. And then we could put comma, comma, and the present value would then be the figure that we gave, the 1,000. Then the unknown is really in this cell. And then what we can do is we can use this function. We can use goal seek, which I highly recommend taking a look at in Excel. And that would be kind of the substitute of using algebra. So we can use the same function, which is a more well-known function than a function that could be in Excel that would solve for the number of payments, to then find another unknown, in this case being the number of payments. And then you could basically solve for that, and it could find you then the number of payments in that format. Let's go back up top and look at it another way, this time with our running balance type of calculation. This is not something you would probably see in a book problem, but if you have Excel, you can do a running balance type of format like this. Really useful calculation to do it. So if we were to see this format, we could say, okay, let's start off with that 1,000, which we're saying that's going to be our original investment. And I'm just going to do this running balance until we get up to 2,000. So that's when it would double. So I'm just going to go period by period until we get up to 2. So we just go, okay, we got the 1,000 times the 6%, 0.06. And that's going to be $60 on the interest. And the $60 plus the original 1,000 gives us the 1,060. That times the 6% times 0.06 is going to give us the 63.6 or 64 about, plus the 1123.6, and we would go on and so forth. This would be very tedious to do with a calculator, but in Excel, quite easy because we can use the autofill to do that. We do have this problem in Excel, so you might want to take a look at that. And when we get down to here between 11 and 12, we can see, okay, now it clears. It goes past the 2,000 in between there. So we know then that it's going to be somewhere between period 11 and 12. If we wanted to break it down further, we can then say these are years that we're talking about in terms of the periods. So there's 12 months we can say in there. So this 114, if I take that 114 and divide it by 12, we could further approximate the information here by saying we're going to apply out for 12 months, 11 to here, because that's going to clear over the 2,000, and continue on with our running balance now on a monthly basis. So after year 11, 1898.3 plus year 11, month 1, the 9.49 would give us about the 1908. And then I'd say plus another another 9.49, and that would give us about the 1917. And so we could see that it's going to be somewhere down here on year 11, between month 10 and 11, that we can kind of find it. So you could use a running balance to kind of figure that out, or at least approximate what it would be as well. Then the other way we could do this is with the tables, which again, it's kind of like an approximation type of format. Tables would probably be best to approximate it. So we can then say, we know if we start with the 1,000 here, that we have to end at 2,000 in order to double it. And on the table, that would mean that we need to find 2 on the table, because 1,000 times 2 would equal the 2,000. We know what the rate is. The rate is going to be 6%. We just don't know the number of periods. So if I go to the 6%, I'm just looking for where 2 shows up. And that's going to be down here somewhere between 11 and 12. So we know that somewhere between period 11 and a 12 from the table is when it's going to go from 1 to 2. And then we could get more approximations by those percentages, but that's another way that we can kind of approximate and back into the number of periods. So let's do it again. Let's say, well, what if it triples? If we do the same thing and say, okay, I need something to triple, we could do it with the formula, and we could say, okay, the original investment, let's just make up a number. It could be 1. We're going to choose 1,000 again. So we're going to say the original investment has a present value of 1,000, which would be PV, times 1 plus R. The R is going to be 6% to the N. N is unknown. The future value is known because it's got a triple. And if we put in 1,000, tripling times 3 would be 3,000. So it would be 3,000 equals 1,000 times 1 plus R, which would be 6% to the N, and then being the unknown. We can work the algebra in that format, or we could use the goal seek in a similar format. So I'm going to break the math down here into our table as we've seen in the past to discuss goal seek, which we probably wouldn't use in a formula like this as much, but rather in the Excel formula for the future value. So this is just, the kind of the precursor to the use of the formula to see how it works. So if we had the 1,000 and then we have the 1 plus 6% gives us the 106, this would then be the unknown. We know that this number needs to be 3,000 because 1,000 times 300 times 3 would be the 3,000. So we got the 1,000 times the 3 is the 3,000. This would then be the unknown. If these were all connected with formulas in Excel, we can use trial and error to basically back in. Instead of doing the algebra and solving for n, we can simply use trial and error and let the system then find it out, plugging in numbers, starting possibly with 10 and just going up from there until we get to approximately 3,000. And using Excel, we can accelerate that by using goal seek, basically telling Excel to do that for us. So that's how we can derive this number in a formula basis. We would probably apply that more likely to something like a formula in Excel. So if we had something like this in Excel, then once again, I'm saying I'd like to solve for this one, the number of periods, but what I want to use is the future value type of formula. Just like we do up here when we have this equation, anything that I'm searching for that fits into this equation, if I only have one unknown, I can use this equation. We don't know n here. If we know everything else, I have one unknown, therefore can search for it. But down here, I can't really do the algebra because it's a function in Excel. And if we have more complex functions, it could be quite complex to figure out what the function means in terms of mathematical terms. What I'd like to do is basically use it in the same format, meaning I'd like to, if any of these are unknown, if I only have one unknown, then I'd like to be able to use this function. The way to do that is to use that goal seek trial and error format. So I could say that this is going to be the future value of the rate, which we know is going to be the 6%, comma, the number of periods. That's what we do not know. So we make up a number first. I put it in another cell. I make up some number like 10, put it in that cell, and then comma, comma, and then the future value, the present value is something that we know because that's going to be the 1,000. So we enter that. That's going to give us a result. What we want is for that result to reach 3,000. So what we would then do is use goal seek to change this number. We can keep changing this number using trial and error till this formula then generates the number that we know it should be, which in this case is 3,000, thereby solving for the number of periods. We could do that manually. In Excel, it doesn't take a whole lot of time, oftentimes manually, to do that, but we can use goal seek to do that more quickly for us, and in that way, even though we don't have a mathematical formula to use algebra on, we can have the same concept using this format, and if there's only one unknown in it, use it in a similar way, finding that one unknown with the use of goal seek, which basically replaces the algebra with a trial and error kind of method to locate the unknown number. So actually quite useful tool. So then we can use the tables, of course, as well to approximate. So if I start with 1,000, I want to end at 3,000 because I want it to triple. that means the number on the table needs to be 3. So I'm looking for 6%, something on the table that gives me 3. So if I go on down here, 6%, I'm going to go on down to where it gets to 3 right here. That's between 11 and 12. So 6%, I'm sorry, I'm on 6%. We need to get to 3. That's 2. 3. I got to count up to 3. That's somewhere between 18 and 17, 18 and 19. So somewhere between 18 and 19 is when it gets to 3 on the table. So that would be an approximation of the period. It would be period 18 and 19. We can then take a percentage of those and try to approximate, how close in between those are. But that's one way we can basically use the tables. Clearly, the tables are a less efficient way to find this answer, but you could see kind of how it works, how you basically back into it with the use of the tables if you needed to.